Hey guys, how's it going? Welcome back to FizzWiz. I'm Manas Sharma, and in this tutorial, I'll be showing you guys how to calculate charge difference density from given cube files, and also to how to calculate density profiles by integrating this density over some particular planes. So essentially, what is this charge difference density and why is it useful? So as you can see in this equation right over here from this paper, so a charge difference density for a system where you have a molecule adsorbed on a surface can be given such as like this. So you will have the density of your total system, that is with the molecule, and then you subtract the density of the molecule, in this case the Li atom, as well as the substrate, in this case the graphite substrate. And this can help you see charge transfer and like does the molecule provide electrons to the surface, or is it the opposite? So you will get some you can get these plots like this, so you can visualize the charge density difference, and you can also get this density profile, on which I also created another tutorial a few days back, where I showed how to calculate these integrated planar density, which is what I'm calling density profile right now. And for the sake of this tutorial, we'll be calculating it for a system where you have this H2O molecule on top of the LiH surface. So this is the density cube file that I have for the total system. And yeah, by the way, for this tutorial, or like for calculating any charge difference density, as you have already seen from this equation right here, or in my case where I have the H2O molecule, the equation will look something like this. So I will have the density of the total system, that is the H2O molecule plus LiH substrate. Then I subtract the density of the H2O molecule and then the isolated LiH substrate. So yeah, so as I was saying, so for any charge difference density calculation, you are going to need these three densities. And in my case, for the sake of this tutorial, I have already calculated them as cube files. So I have all the three densities that I need as cube files. In your case, you may have to generate them beforehand using whatever DFT software that you're using, for example, VASP, Quantum Espresso, Turbomole, and whatever else that you're using. So yeah, so as I was saying, I have the density cube file for the total system, then I have the density cube file for just the substrate, that is the isolated substrate, and then I have the density cube file for the H2O molecule. And another very important thing that you need to keep in mind is that for all these three systems, the cube file should conform to the same cell. So the cell should be the same, because otherwise how are you really going to subtract the two, right? Because then you won't have the density being calculated for the three systems at the same point. So then it will be really cumbersome, and like I don't even know how to do that. So in my case, and you can also check that in your case as well. So if you open these density cube files using any text editor, so let me go ahead and do that. And hold on. Okay, yeah, so this is the H2O cube file. So in the first four lines, you can see or check whether the cube files would be same or not. So here I can see that the origin is just the 0, 0, 0, and then there are 100 grid points in the x direction, 100 grid points in the y direction, 100 grid points in the z direction, and these are the steps sizes of those grids. And if I open the same thing for the total system, then again I will get the same thing. So again you will see that the so again you can see that in both the cases all of this is the same. This you can ignore. I think this is the number of atoms, so this will of course change, but the origin as well as the step size of those grid points should remain the same. So yeah, so let's now calculate the density difference, as we already have these cube files. So as you can imagine, you need to subtract these cube files. So for that, we will head over to this tool that I created for Turbomole, that is reporttools.turbomole.org, and then you will head over to cube processing. So since we are working with cube files, and then you can hit this button to visit this cube suite app that I have created again. And let me go ahead and close this old link. So yeah, so here it is. So the first thing, as you can see from this equation, is we need to subtract these two. So what you can do is basically you can just add the isolated densities and then subtract the added or the sum of these isolated densities from the total system. So let's go ahead and add these two. So we'll head over to this add cube file option in the sidebar, and then you will drop the first cube corresponding to the so my density plots are here. So yeah, so that would be H2O, and then I will drop and upload the second density, that would be the LIH substrate density. Now you can just go ahead and wait for it to upload. It should take a moment or two. Okay, so the uploads are now complete. So let's now go ahead and hit this add cube files button and wait for them to be added. And now you will get this download summed cube file. So let's go ahead and download that. So here it is now in my downloads directory. So let me go ahead and get that and put it in my main directory. Let's visualize it using Vesta. So let's see how does it look. So now you can see that so one of the cube files only had the information for just the substrate, the other had the information for just the H2 molecule, but now you are able to see both of those. So yeah, so it has worked quite well. And now next what we are going to do is we are going to subtract this from the total cube file. So let's go ahead and come to subtract cube files, and once again we'll do the same thing. So we'll upload the total density, that would be the first file from which you are going to subtract stuff, and then in the second you will provide the summed density. So let's go ahead and do that. Okay, so uploading is now complete, and now you can hit the subtract cube files button to get the final charge difference density. That will help you see any charge transfer that might be occurring or not. So let's now just wait for it to download. And yeah, so once we'll have this file, we'll also visualize it with Vesta. So let's go ahead and again get this from the downloads folder and put it in the folder that I'm working in. So yeah, so now let's go ahead and visualize it. And here it is. So now you can see that there is some stuff happening in this region. So one of them indicates, one of the colors of the isosurface indicates a positive sign, while the other indicates a negative sign. And from that you will get this information about the charge transfer. And finally you can also use this planar averaged or planar integrated rather utility, and you can just go ahead and upload this difference density cube file here, and then you can select the axis along which you want this to be calculated. So let's see the charge integrated density profile along the z-axis, because that is usually what you'll want to see. For example, here as well, it is along the z-axis. So yeah, so here we are, and yeah, so here we see. So here we see that there's something happening right where the molecule is. This is all vacuum, so nothing there. And then due to periodic boundary conditions, it now goes down because it's seeing the substrate from that side. It's coming from here. But yeah, so mainly whatever is happening is right where your molecule is. So yeah, so that is basically it. That is how you calculate charge density difference, as well as how you calculate its integrated density profile along a particular axis. And yeah, so I hope you guys enjoyed this tutorial and learned something useful in case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.